Here's a problem that sounds trivially easy but actually turns out to be absolutely brutal. Trying to get a computer to recognize a cat in a photo. Welcome to this explainer. Today we're diving straight into this wild gap between human intuition and machine logic.
It really is the ultimate irony, isn't it? I mean, think about it. A 4-year-old child can do this instantly, literally without even thinking. But the absolute best programmers in the world, they spent decades completely failing at it. Honestly, understanding exactly why that happened is hands down the fastest way to grasp what machine learning actually is.
Part 1. The old way, writing the rule book. Let's look at how software was written from the very beginning. Basically, the whole idea was that you had to give the computer explicit, rigid, logical rules. So, imagine you're sitting down as a programmer, right? And you're really thinking about cats. What makes a cat, well, a cat? You'd probably write a checklist. You'd say, okay, a cat has pointy ears, it's got whiskers, fur, 4 legs, and a tail. Then you translate that into a program. If the image has pointy ears and whiskers and fur and a tail, boom, call it a cat. So you take that explicit code, you run it on real photos, and it's right about 73% of the time. Honestly, not too bad for a first try.
But then we get to part 2, the embarrassing failures, breaking the rules. Because the second this kind of rigid logic hits the real world, it starts falling apart in just incredibly embarrassing ways.
For example, you show your program a photo of a hairless Sphinx cat, and the computer basically says, nope, not a cat, simply because that fur rule you wrote wasn't met. Or you show it a Scottish Folds, the breed where the ears bend forward and down. Total miss. Why? No pointy ears. Then you show it a Manx, which has absolutely no tail at all. Rejected. You even show it a totally normal cat, just curled up asleep with its legs tucked underneath it. Rejected again. Now, every single one of these is so obviously a cat to any toddler, and yet your highly engineered program is just confidently wrong. So, what happens next is just a massive headache. You do what any determined engineer would do. You start adding exceptions. You write a new rule for hairless breeds, another one for folded ears, missing tails, sleeping poses. But here's the catch. Every new rule fixes one specific case, while quietly breaking 2 others. Fast forward 6 months, you're staring at 12,000 lines of code, 1,500 separate rules, and you've barely clawed your way up to an 89% peak accuracy. And the worst part? You're still missing cats sitting in weird angles or in bad lighting or just hiding behind a chair. Now here's the fundamental problem. You're trying to write down as explicit logic something no human being ever actually learned as explicit logic. I mean, think about it. Ask yourself, did anyone ever hand you a rule book for cat? No, of course they didn't. You just saw a bunch of cats when you were a kid and your brain kind of magically extracted the underlying pattern. That's why you can instantly recognize a cat you've never seen before in some weird pose you've never seen, and yet you can't fully explain how you do it. The knowledge is incredibly real, but it's just not a checklist of rules. Which brings us to part 3, the machine learning shift, flipping the approach. That exact realization leads us directly into the core concept of machine learning, which literally flips the entire engineering approach completely on its head. Let's see how this creates a totally new paradigm. Instead of painstakingly writing out the rules, you just collect examples, say 200,000 photos, and each one is clearly labeled cat or not cat. Then you just feed all of them into a neural network. And step 3, you let the network discover for itself what actually separates them. So the absolute crucial point here is that nobody is telling the computer to look at fur or pointy ears or tails. It figures out entirely on its own that things like face proportions and overall shape actually matter way more than any single isolated feature. And guess what? After just a few hours of training, the network hits a whopping 96% accuracy. It completely destroys the absolute best results you got from those 1,500 frustrating handwritten rules. But you know what the most satisfying victory of all is? It absolutely nails that hairless Sphinx that broke your very first version of the code. Why? Because it never cared about a strict fur rule in the first place. This right here is the fundamental difference between the past and the future of computing. We've moved away from exhausting ourselves trying to write explicit rules to a world where we simply provide massive amounts of examples. That is the big shift that made modern AI possible. So the ultimate takeaway I want to leave you with today is this. Stop trying to write the rules, give the machine examples, and just let it learn the rules itself. Because honestly, if our own brains don't use rigid rule books to understand the world, why in the world should we force our computers to?